My interest in this line of research was basically arose from two contributing factors. One of those was the mentorship that I received very early on as an undergraduate student. I was always curious about how one might go about thinking about human health and then methods and technologies to improve human health. And as an undergraduate student, I approached one of my mentors at that time, Dr. Justin Haynes, who is actually a chemical engineer by training. And I got really excited about some of the work that was ongoing in his lab, which was essentially in the area of developing these engineered materials. And he was applying them to all types of different human diseases that had unmet medical needs. And so as an undergrad, I got involved in that research, got very inspired by it, both from my mentor, Dr. Haynes, and also from the other folks that I was working with in the research group. And so that really led me to the next stage, which was graduate school. And there, I think there was a combination of two things. One, certainly the mentorship that I received, which was really formative. And then the other aspect was my own curiosity. When you get involved in research, you get more curious and you start asking questions because you start understanding things more than what you may have understood before. And so your curiosity is increases, and that basically led me to the next step, which was graduate school. And there again, I continued receiving a really strong, really wonderful mentorship as well from my PhD advisor, Dr. Paul Hammond, who basically gave me a project that I could really sink my teeth into, which was in the area of developing new types of materials for musculoskeletal diseases, including regenerating bone and cartilage. And so that really got me interested in that aspect of human health and the conditions that are associated with musculoskeletal disease, which includes arthritis, all forms of arthritis. We are focused on a specific type of musculoskeletal disorder, the rheumatoid arthritis. There are two aspects. One, sort of the effect that the disease, the way the disease manifests, which is primarily inflammation in the joints, but also what the patient experiences, right? And as scientists, we often just think about one aspect, which is basically the disease pathology, how it presents itself, which is inflammation, and how we might be able to go about treating the inflammation. And it's very effective, but oftentimes, we think about that as sort of a standalone problem. But one aspect that we've just started to think about is what the patient experience might be, because even if we treat the inflammation, which is sort of the manifestation of the symptom of the disease, patients sometimes continue experiencing other aspects of the disease. This includes pain. And so we have started thinking about the disease not so much as as an individual symptom that needs to be treated, but sort of more holistically in terms of the different aspects of the disease, which might include multiple symptoms. It might be different for different patients. But what we're going about thinking, the way that we're going about thinking about this is try to understand what are the causative factors that cause these symptoms. And it turns out that the immune system has a central role in all of the manifestations of autoimmune arthritis or inflammatory arthritis. And what we're interested in looking at is how we might be able to modulate immune cells to go after these different symptoms, not so much as a standalone treatment, but more holistically in terms of rebalancing immune cell subsets that ultimately should hopefully result in not just treating one aspect of the disease, but improving the patient experience overall. I guess the challenge is oftentimes as a patient, one might not be aware of what all of the options are that are available to them. And so trying to read up on, there are a whole bunch of sources where you can collect this information. And so, for example, the ANRF website, has a lot of that information and also sources that if you're interested in further reading. But if it's possible to read up on what the disease is about, what the different treatment options are, I think it'll just help to have a more informed conversation with the rheumatologist. The rheumatologists are trained very well in prescribing medications, and if one doesn't work, then the next, and so on and so forth. But just being aware of what the different options are just helps you expect and anticipate what the steps would be that would hopefully ultimately result in treatment or disease control in the patient. We've been actually thinking about ways to try to see if we can diagnose RA even before the symptoms manifest, because primarily the reason why someone would show up in a primary care office or a rheumatologist's office is they have a swollen joint or they're experiencing pain, and that's the reason you'd go see a doctor. If you're not experiencing the symptom, there's no reason to go to the doctor, right? That's how medicine, the current state of medicine is. What we're thinking about is, could we, for example, identify patients that might be at a higher risk of developing RA, and this, so certain risk factors have been identified, including genetic factors and so forth. What we're thinking about is from an engineering standpoint, from a material science standpoint, could we think about designing an approach that would help potentially diagnose and identify patients that are already experiencing rheumatic disease, but it isn't quite to the point where the symptoms have manifested, so they don't have inflamed joints, for example. So that's an area that we're very interested in as well. Fairly early on, I think in my career, I would say it's a journey. So that's the way I see it, and there will always be challenges along the way, and the successes that we've had, the challenges are shared and the successes are shared. So for me, I think one of the things that so I'm a more sort of basic scientist. I'm not a rheumatologist. I don't treat patients. So we focus primarily on research and doing things in a research lab. So what is just absolutely critical and essential for us are the people that we work with. And so one thing you'd ask a question about what is something that as a scientist I wish patients knew. I truly wish that they knew that the science, that the people that are behind the science that's being done, right? These are at least in my lab, these are students, and these are undergraduate students, like I was at one point, graduate students, PhD students that are pursuing a doctoral thesis, and these are the folks that are really sort of in the trenches doing experiments, sort of troubleshooting on a daily basis, experiments, and oftentimes most of the experiments that we do, they do not work, and so that's something that is really important for people to know. And it's not because the reason why it may not work, there might be many reasons, some of them really obvious reasons that in hindsight we should have thought about and anticipated, but oftentimes these experiments don't work because of reasons that are beyond our control or unanticipated, the results that we get are unanticipated. And I want to just mention that, an experiment not working is not necessarily a bad thing. You still learn from it, and then you design a better experiment that eventually allows you to get to an answer that you're seeking. So it's an iterative process. Most successes that we have are not overnight. They're years and years of work. Often not by one person, but by multiple individuals. So it's a concerted effort, and it takes a lot of time, energy, and patience, and of course funding, so that we can continue doing the experiments. But really, this puts into focus the people that are just central and essential for this endeavor. And so each time my student is successful, I would consider that to be a success for the lab and for science in general. And that success can be a variety of things. Students, for example, running an experiment that gives them an answer, and that might be a good answer or a bad answer. It doesn't matter. It's an answer. If we get an answer, that's a success, right? If we publish a paper, that's a success. If we receive support to continue our research, that's success. If students receive their own fellowships, that's success. And we celebrate these successes, and because it really allows us to get to our goal, the ultimate goal, which is to develop newer and better therapies for patients, and in this case, particularly for patients that have rheumatoid arthritis. So again, this is a journey, and I take students along with me on this journey, the students that are interested, and I've been fortunate to have just fantastic folks to work with in my research group, and I'm tremendously thankful for that. Because they've really not only sort of implemented the ideas that I have, but also formulated their own ideas and sort of took this project in directions that I would have not imagined starting out. I continue to look forward to doing that, throughout my career. So. ANRF support has been just absolutely transformative for my group, and I'm not saying this lightly. Both from a financial standpoint, of course, receiving the grant money was a great honor. It supported experiments in my lab that would otherwise have been challenging, difficult to do. And the other aspect about ANRF was that at the time of application, I identified a mentor, Dr. Nishag Shah, who himself is an ANRF grant recipient from several years ago. And my collaboration with Dr. Bottini is a central reason why we've been able to take this project as far as we have. Dr. Bottini over the years has worked with several arthritis mouse models, which is one of the key ways in which we go about testing our approach. And so having expertise and access to some of those mouse models was absolutely essential for us in order to show proof of concept that the approach that we have has value in terms of pursuing it further. And Dr. Bottini actually still co-advises two of my graduate students who are working on the projects that have been supported by ANRF. And so having resources to conduct the work is critical, and resources include certainly financial support, but also people. And I keep coming back to this idea that people are essential for the success of science. So they're trainees and students that are highly enthusiastic and motivated, and also collaborators like Dr. Bottini, who have the expertise, the several years of knowledge about arthritis, and someone who I've enjoyed tremendously working with, and actually learned a whole lot from. And we have continued our collaboration, and we have several years of projects planned. And it's one of those rare, I think, connections that are frankly difficult to come by in academia. But if you make those types of connections, you can have almost a career's worth of work that can be very satisfying and also very impactful.